Hello, geometry students. Here's your lesson for section 3-4, perpendicular lines with Missy McCarthy, math instructor at Okemos High School. By the end of this lesson, you should be able to say, I can apply theorems about perpendicular lines, I can recite, apply, and prove the perpendicular transversal theorem, and I can define the distance from a point to a line and identify the shortest distance in a diagram. So first, we're just going to talk about what the shortest segment is from a point to a line perpendicular to a line is. So if we take a look at, if I were to draw a line here, let me get a different color that you can see. And this is line L, and we had a point P not on that line, and we wanted to find the shortest distance from point P to line L. Essentially, what this says is the distance from a point to a line is the length of the perpendicular segment from that point to the line. So while you may be able to draw several different segments from the point to the line, this one actually is always going to be the shortest segment. So if we look at this, we have our line here, line BC. I'm also going to label it line L. And then we have several different segments coming from point A. So point A is here, and we've got AC, AP, and AB. So it says name the shortest segment from point A to line BC. Well, the shortest segment has to be the one that's perpendicular, so the shortest segment is segment AP. Now it says write an inequality and solve that inequality. So if AP is the shortest, that means that segment AP, or the length of segment AP, is shorter than that of AC. And since we know AP is 12 and AC is x minus 8, we can solve this inequality for x by adding 8 to both sides. We add 8 to both sides, we get 20 is less than x. Or another way to write that would be x has to be greater than 20. So we have three different theorems about perpendicular lines. The first theorem just deals with having two lines, L and M, and it says if those two lines are intersecting and they form a linear pair of congruent angles, then the lines are perpendicular. So if we have line L intersecting with line M, and they form a linear pair of two congruent angles, then it is safe to assume that those angles are right angles, and therefore L is perpendicular to M. This theorem doesn't have a name, but if we were to use this theorem as our justification, we would just write two intersecting lines form a linear pair of congruent angles. That implies that the lines are perpendicular. The second theorem does have a name. That's called the perpendicular transversal theorem. And it says that in a plane, if you have two lines that are parallel, and you have a transversal, and that transversal is perpendicular to one of the parallel lines, then it is safe to assume that the transversal is also perpendicular to the other line. And then the last one says, if you have two lines, and you have a transversal, and the transversal is perpendicular to both of those lines, then it's safe to assume that those lines are parallel. Again, this does not have a name, although we spoke in class and we called this the converse of the perpendicular transversal theorem. But if you were to use it as justification in a proof, you would use this. Two lines perpendicular to the same line implies that those two lines are parallel. So let's apply the theorems about perpendicular lines. So I'm going to use that one right now. I've got a line here, and then I have two lines. I'm going to call this line L and this line M, and they are both perpendicular to what I'm calling line N. Okay, so because of that last theorem that we just talked about, we know that these two lines are indeed parallel to one another. All right, so that's the first thing. We know that those lines are parallel. So now I'm going to change my focus from those lines to this one now being my transversal. So I have two parallel lines cut by a transversal. I know lots of different things. I know alternate interior angles are congruent. I know alternate exterior are congruent. I know same side interior are congruent, and so on and so forth. So I can say this one and this one, which are alternate exterior angles, are congruent. So that means 2y is equal to x plus y. All right, so we've got that. Now we also have these two that we're looking at, and I know that they are supplementary because they form a linear pair. So x plus y plus x is equal to 180. So that gives me two equations and two unknowns, and I should be able to use those to solve for x and y. I'm going to simplify this one. This equation just becomes 2x plus y equals 180. Those are the same equation. So this is my first equation, and this is my second equation. So this one, this 2y, I'm going to take this equation and I'm going to do a little substitution. I'm going to start with my 2y equals x plus y, and then I'm going to subtract y from both sides. So if I do that, I get y is equal to x. So that means I can substitute this into this equation where I could have 2y plus y is equal to 180. I replaced y with x. That gives me 3y is equal to 180, which gives me y is equal to 60. And then that means that x is also going to be equal to 60. So I used what I knew about perpendicular lines and transversals, and then I used what I knew about parallel lines to set up a system of equations and solve for x and y. All right, so the last thing we're going to do is a little proof practice with those perpendicular proofs. So the first thing we know is that R is parallel to S. I'm going to put my parallel line marks on there. And we also know that angle 1 is congruent to angle 2. We've got to try to prove that R is perpendicular to T. All right, so first we've got R is parallel to S and angle 1 is congruent to angle 2. Those were given to us. Next, we're going to say angle 2 is congruent to angle 3. How do I know that those are congruent? Well, if I'm looking at angle 2 and angle 3, I see that those are corresponding angles. So I have two parallel lines cut by a transversal. Corresponding angles are congruent. That is the corresponding angles postulate. All right, so I know that those are congruent. Well, I also know that 1 is congruent to 2 and 2 is congruent to 3, so that means 1 is congruent to 3. That would be the transitive property of congruence. Transitive property of congruence. So now I've got that 1 is congruent to 3. So that means that R has to be perpendicular to T because of that first theorem, which doesn't have a name, which says if you have two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So that was a little proof practice with some of those perpendicular line proofs. Okay, again, make sure that you can apply the theorems about perpendicular lines like we practiced in class, that you can recite, apply, and prove the perpendicular transversal theorem, so you might want to give that a try, and that you can define the distance from a point to a line and identify the shortest distance in a diagram. You may also have to set up an inequality and solve. That's about it for section 3-4. See you in class.